Okay, folks, this is a recap of week 2. So in week 2, we were looking at chapter 2, which is atoms, molecules, and ions. One of the pieces that I think is really important for you to see is that as we're thinking about lab, here's some contact information for you with respect to your lab instructors. These are really important people to connect with. They're going to help facilitate your success in lab. They're really phenomenal chemists or biologists who have significant chemistry experience, and they'll be able to answer the questions that you have. I want to take a look at the following question. So a sample of seawater contains 0.075 grams of sodium chloride per milliliter of solution. How many moles of sodium chloride are there per liter of this solution? A mole of sodium chloride is equivalent to 58.5 grams of sodium chloride. So we're going to set up this dimensional analysis. A really important component to identify is that the order in which you do your unit conversion doesn't necessarily matter. So for example, in this problem, I looked at 0.075 grams and I converted the grams to moles by dividing by the molar mass of 58.5 grams. And I could have found that by looking at my periodic table. But I also, if I wanted to, could have converted milliliters to liters first. So again, the order doesn't matter because what you're doing is multiplying and dividing. As long as you multiply across the top and you divide by what's on the bottom, you're going to come out with 1.282 moles per liter. And it's really important here that we notice that of the information that we're given, we actually have 2 sig figs here, as opposed to 3 sig figs here. And so our answer is 1.3 moles per liter. Just a quick recap on norms. So we are committed to creating a safe space for everyone to learn. Part of that means that questions are always welcome. Another part of that is that you can rely on others. We collaborate as scientists when we're trying to make sense of new knowledge. And then we iterate. So that means that we're willing to try again. I think that's actually probably one of the most important components of learning chemistry. Our scientist spotlight was taking a look at Dr. Clive O. Callender. So he actually attained a bachelor's degree in chemistry, and then he went to medical school at Meharry Medical College. And after that, he did multiple fellowships to become a transplant surgeon. But what I wanted to highlight and showcase is that he developed the efforts to create a national minority organ tissue transplant education program. And it's because of that work that many patients can receive organs for transplant. So he's an exceptional example of a scientist we want to spotlight and someone that we can look up to and aspire to be. I wanted to talk a little bit about the Chem 110 mindset hack. So we've talked about creating a safe space for learning, but some of that is also dependent upon our own mindset. So many people mistakenly believe that the ability to learn is a matter of intelligence. But the reality is that everyone can learn. In fact, learners are made, they're not born. So through the deliberate use of practice and dedicated strategies to improve our ability to learn, we can all develop expertise more effectively. That's really critical, especially because we're going to need to practice. And some of the questions that are worth asking are, does practice mean repeating the same skill over and over again? Does practice require feedback? Should practice be hard? Should it be fun? How are you going to practice? And so one of the ways that we're going to practice is using ALEX. So ALEX uses artificial intelligence to map the details of each person's knowledge. So another way to say that is that ALEX knows at each moment, with respect to each topic, whether you have mastered that topic. And so you'll have the opportunity to practice the topics that you haven't mastered and then move on once you've mastered a topic. Really critically, according to research from Johns Hopkins, what they found is that if you practice a slightly modified version of a task you want to master, you actually learn more and faster than if you just keep practicing the exact same thing multiple times in a row. Well, what's the reason for that? They hypothesize that the most likely cause is reconsolidation, or a process where existing memories are recalled and modified with new knowledge. So another way of saying that is that reconsolidation, or a practice where you try something a slightly different way or in a new context is going to improve learning. There are a couple of strategies that we're going to use when we reconsolidate. So one of the strategies is reframing. Can I say this another way? Can I ask the question another way? Another strategy is curiosity. So you could say, I wonder, and then think about changing a variable. Another strategy that you can use is being mindful of process. So I notice or I observe that I use these steps when I solve a problem. But there are some other strategies that we can use when we're reconsolidating too. We can engage in radical collaboration. So we can work with someone else who might explain the problem a different way. And we can also think about bias towards action. So what's my next step? If I get stuck, where can I go for help? If I'm successful, how can I deepen my learning? Importantly, we want to talk about some very real burdens and barriers to learning. The imposter syndrome is basically believing that you don't belong or that you don't deserve to be somewhere. The sensation often leads to anxiety or depressive thoughts about whether you can keep up. Stereotype threat is when people feel themselves to be at risk of conforming to stereotypes about their social group. So how do we create a learning space where everyone feels safe? Well, I think the most important space is that you have the opportunity to iterate, that everyone has the opportunity to belong, to participate, and to try again. So our learning outcomes for Monday in week 2 was to distinguish between chemical and physical changes, to be able to distinguish between states of matter, and then to distinguish between ionic, molecular, and acidic compounds. So when we think about chemical and physical change, for the physical change piece, we want to really think about how we can gather information. And so part of that is thinking about scale, how big something is, how small something is. I use this general scale as a reference frame. So galaxies are the size of 10 to the 15th. A human being is 10 to the 0 meters. That's the same thing as saying 1 meter. Whereas an atomic nucleus is 10 to the minus 15th in scale or size. We used a decision tree to help us make sense of matter. So we observed that matter occupies space and possesses mass, that it can exist as a solid, liquid, or a gas. We then observed that there are 2 different types of matter. There are pure substances. This is matter that has an invariant chemical composition and distinct properties. And then there are mixtures. Mixtures consist of 2 or more pure substances that retain their individual identities and can be separated by physical methods. If we're thinking about pure substances, there are 2 types. There are elements that cannot be separated into simpler substances by chemical methods. And then there are compounds. These are substances composed of 2 or more elements in fixed proportions. These can be separated into simpler substances and elements, but only by chemical methods. If we're thinking about mixtures, we also have 2 types. We have homogeneous mixtures. These are mixtures that have a uniform composition and properties throughout. This is also called a solution. And then we have heterogeneous mixtures. These are mixtures that are not uniform in composition and properties throughout. Interestingly, we also need to make sense of the different states of matter. So solids are rigid, they have a fixed shape and a fixed volume. Liquids are not rigid, they have no fixed shape and no fixed volume. And gases are not rigid, they have no fixed shape and no volume. When we're thinking about changes in state, it's important that we think about 6 critical terms. These terms describe what is occurring at a molecular level, so between individual molecules. When we think about melting, that's the transition from a solid to a liquid. When we think about freezing, that's the transition from a liquid to a solid. When we think about condensation, that's the transition from gas to a liquid. When we think about boiling, that's the transition from a liquid to a gas. When we think about sublimation, that's the transition from a solid to a gas. And when we think about deposition, that's the transition from a gas to a solid. You're going to want to have a working definition for each one of these academic terms. It might be helpful to put them on a flashcard, or you can use other ways to review if those are better suited to your learning. We also want to make sure that when we look at models of an atom, we have an understanding of how big its components are. So for example, if we're looking at the nucleus, right, that's typically 10 to the negative 15th meters, whereas the whole atom would be 10 to the negative 10th meters. And it's really important that we note here that 10 to the negative 10th meters is 100,000 times bigger than 10 to the negative 15th meters. Inside of our nucleus, we have neutrons and protons. Notice that the neutrons have no charge, whereas the protons have charge. And then here you can kind of see the gray, but this is an electron cloud. And electrons are really tiny relative to the size of the nucleus. The last thing we're going to talk about is diatomic and polyatomic atoms. So you can read about these in chapter 2, and it's going to be really useful for you to have several that you can recollect. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Notice they form the number 7 on the right-hand side of the periodic table. We also have elements that exist as polyatomic molecules. Examples of this are phosphorus, sulfur, and selenide. The two that I think are most important for you to know about are phosphorus, P4, and sulfur, S8. Last couple of pieces of information here. So Science Student Success will meet from 11:30 to noon on Mondays and Wednesdays after class. We solve problems, everyone's welcome. We're going to think about how to familiarize you with the type of problems, connect you with resources, help you apply your knowledge, help you analyze whether or not your answers are reasonable, and then be able to evaluate your learning. You also get some really phenomenal practice in your Chem 110 discussions. Those are Thursday in the library in room 1128. And then I noticed that in the last 5 minutes of class, folks are thinking about packing up. But I really want you to take a pause and practice, because this week we were learning how to do this, but next week I'm going to be grading this activity. So in the last 5 minutes of class, I need you to organize your goals. So in order to develop your knowledge or an area of expertise, we have to set achievable goals. Then we have to think about how you're going to meet those goals. When we set short-term targets, that helps us achieve progress. So for example, if you're thinking about dimensional analysis, you might want to set a goal around dimensional analysis. For metacognition, this is thinking about thinking. So how do you know what you know? It's actually a matter of asking a question like, do I really get this idea? Could I explain it to a friend? Do I need more information or knowledge? Or do I need more practice? So metacognition is just taking the moment to stop and reflect on what you've learned so far. So when you're reflecting, you might need to ask some questions like, what made sense? What might need refining or reframing? What are you curious about? Who do you learn well with? What might be your next steps? If we're thinking about what's coming up next, by Sunday, February 2nd, you want to make sure that you're reading up through chapter 3. And by Tuesday, February 4th, you have your second reading quiz also for chapter 3. Remember, you always have your Wednesday in-class quiz. Mondays are always your opportunity to make up in-class quizzes if you need the additional practice. If you don't, then you can just think of that as extra practice that you don't have to turn in. Thanks. Appreciate your hard work, your focus, and attention to detail. We'll talk to you soon.